Good morning, everybody. Just getting my camera set up here. Thanks so much for joining. We've got a big crowd here this morning, so thanks for registering. Thanks to those of you who are familiar with Photo Ephemeris and use the tool and are supporters. We're very grateful to have you. So we still got a few folks rolling in. So this webinar today was originally sent out to users of the Photographer's Ephemeris, which is a photography planning app, well known, I think, to landscape photographers, outdoor photographers, moon, night photographers. And I think we got, as I mentioned, the word is spread of this, and I think the interest in the April 8th eclipse is very high. And so we have some folks that may be less familiar with the tool or our software. So I'll spend a little bit of time just to cover the basics and get everybody up to sort of a level set, so we can go through the agenda together. I would like to make a very warm welcome to a special guest this morning, Michael Zeiler. Michael, if you're there, hello, there's Michael. I think you're muted, Michael. But
Hi there, Stephen, and everyone out there.
It's really great to have Michael with us. Michael is his wife are the founders of Great American Eclipse, and Michael's a very long time eclipse chaser, and you've been doing it what, 30 odd years now, Michael?
Yeah, since 1991, I was smitten after that eclipse.
And Michael is a lot more than just an eclipse chaser. I think just to put in some context here, eclipse maps have been around for many centuries, and you can go back to Halley in 1715, who I think was one of the earliest people in the modern era to do an eclipse map. And you can set me straight on that if I'm wrong, Michael.
Well, actually, the first was in 1654 by Erhard Weigel in Jena, Germany. That was the first eclipse map.
So a tradition that dates back to 1654, and we are privileged today to have the world's leading exponent of eclipse cartography as a guest on the webinar. So thank you, Michael, for joining. Michael's going to do two things. He's going to give his perspective and experiences as an eclipse photographer, and then we're going to talk in a little bit more about some of the latest maps that he's created. So Michael's maps are extremely rich in terms of the types of data they can represent, and they show things that are very difficult or almost impossible to do in a tool like Photo Ephemeris or other online maps, where things are a bit more constrained in terms of how much you can calculate and show. Michael does a ton of work ahead of time to create his maps, and perhaps, Michael, you can tell us a little more about that later on, and the process of getting to the latest thing, the double diamond maps, which appeared this week. And then we're going to try to join the dots for you all and link Michael's latest maps back to Photo Ephemeris, back to planning. And at the end of the sort of the demo part of today's session, we'll walk through an actual, well, no, I say an actual, a simulation of an eclipse in a location that's going to happen on April 8th. So you get a sense of how this thing is going to play out and what you're going to need to be thinking about and experiencing as photographers. So that's the plan. So Michael, thank you. I will welcome you back again a little later in the presentation. We'll see you in a while. I'm going to start my screen share now, and we'll jump into the main content. Here we go. Okay, there's the screen share. So let's have a look here. Okay, I've introduced us, so we can skip past that. I've introduced Michael. That's his website, greatamericaneclipse.com. So please have a look at that. Feel free to screenshot these slides as we go. I will post this presentation afterwards along with the recording. You'll all get that via email, so it should be good there. Some other resources that I want to mention up front. So we've had a ton of questions come in advance for this, and thank you for all of them. It's been very useful. I'm not going to be able to cover everything that you've asked about today, but I want to make sure that I leave you with some pointers to things that will give you those answers if it's something that we don't really cover today. Obviously, Photo Ephemeris, our own website. We have planning and timing tools that we'll show you today how to use. We'll learn a lot more about Michael's maps on greatamericaneclipse.com. Two other resources that I think are extremely valuable. Alan Dyer runs the site AmazingSky.com, and he has an Eclipse book available, which is very, very highly recommended. And it's a comprehensive book. It covers basically every eclipse photography technique you might imagine, from the most basic to the most sophisticated. So for an in-depth look at that, check out that book. It's great. And then finally, I'd like to mention Fred Espenak's site. Fred Espenak is a most eminent eclipse expert, worked at NASA for many years, developed a ton of material on eclipses, including a lot of the numerical data that underpins the predictions that go into Photo Ephemeris and other tools like it to tell you the timings and the locations. He has a page, the link is there on screen, which is, it's a single page, and if you only read one thing about eclipse photography, read that page. It's very concise, it's an expert summary, and it's what Alice and I read in a cafe in Nebraska in 2017 at 6 o'clock in the morning as it opened on the day of the eclipse. We weren't as prepared as we're going to be this time, so it's highly recommended. About you, the audience, let me just share with you who's here today. So we had over 1,000 people register for this session. The x-axis is the number of folks who responded, and the y-axis is the number of total eclipses that you photographed. So as you can see, the vast majority of folks have not photographed a total solar eclipse before. A significant number have photographed one, which I'm guessing mostly may be the 2017 eclipse. A decent number at 2 to 5 eclipses, and then we have a handful of real experienced expert folks who've done 5 or more. So that's our audience, and with that in mind, well, next slide. These were some of the things that you mostly asked about, sort of my attempt at a word cloud. So filters, when do I put them on? What type do I need? When do I take them off? General equipment and gear questions, camera settings, planning and location, and of course, safety. We'll cover all of those this morning. This slide sort of attempts to summarize the spectrum, if you will, of eclipse photography technique and the sorts of results that you might achieve. So again, on the x-axis, cost, complexity, and risk. So how much does it cost you to buy the gear, to operate it? How much is involved that may go wrong on the day, increasing from left to right. And then on the y-axis, loosely speaking, increasing quality of the imagery that you might capture and the variety of different images that you might be in position to capture as well, based on things like the amount of gear you have, the numbers of lenses, the numbers of cameras, dynamic range, the ability to manage filters, all of that sort of stuff. And sort of on the extremes, we have a multi-camera telescope with tracking and automation, so it's connected to a laptop that's firing the cameras at particular times. You can do that with a single camera or telescope as well, with camera automation. You can have a DSLR or mirrorless camera on a tripod on a tracking mount. A tracking mount is something that will essentially reorient the camera to keep the sun in frame as the eclipse progresses. So in theory, in principle, it's one less thing for you to worry about. And certainly if you're using a very long focal length, it can be handy because it can be difficult to reposition, and the sun and the moon are moving in and out of the frame too quickly to avoid having to retarget. So that's when you might look at a tracking mount. And then of course, a DSLR or mirrorless camera on a tripod. That, I think, is where we're going to focus most of our attention today. That represents the majority of Photo Ephemeris users and the majority, I think, of serious photographers who are looking to capture this, but may not yet have started this progression towards the right. And then there'll be some folks who want to just enjoy the eclipse, grab some footage on their smartphone. And video is a very good option with smartphones. I'm not going to spend much time, if any time, really talking about that option today. But Alan's book is excellent on all of these. Alan Dyer's book. So check that out if your interests lie up here, particularly tracking mounts and multi-camera setups. He's good on, as well as of course these two. Okay, let's talk about safety. I want to make sure that you've all heard this loud and clear up front. Never look at the sun without certified solar eclipse eye protection. So for Eclipse glasses and other eyewear, this is the ISO standard that you're looking for. Read the instructions, inspect anything that you already have to look for damage and so forth. If you're recycling from 2017, the material might be fine, but you need to just double check it, hold it up to the light without looking at the sun, and check for holes, that sort of thing. So no sunglasses, ND filters, no. They're not going to do it because they don't protect against UV and infrared. Stacked filters or sunglasses to try to make it dark enough, not really. Not even some specialized solar filters. I have some solar filters I'm going to show you later on. We'll look at some gear. And the particular one I just waved there it is not one that you should look through. It protects your camera, but it doesn't protect your eyes. So it's not the same thing. Welding glasses, yes, that is a possibility. You have to get, I think, minimum number 13 or 14. But to be honest, in this day and age, Eclipse glasses are relatively easy to come by. And I would encourage you to use those. They're much lighter weight than carting welding glass around. For your camera and for your binoculars, do I need a solar filter? Yes, except for totality, when it must be removed, otherwise you will see nothing. If you haven't looked through a pair of Eclipse glasses or a filter, they take out 99.999% of the light. And if you leave it on during totality, you won't see a thing. But if you don't have one on your camera and you leave it pointed at the sun for the duration of the partial eclipse, we'll look at the timings of all this shortly, you'll probably damage or melt your camera's sensor. There are videos online that show this. They're amusing to watch, as long as it's not your gear. Or worse, you could permanently damage eyesight. So don't assume that the solar filter for photography is good enough for your eyes. And because that is the case, on a DSLR, use live view, or on a mirrorless, you'll be using your electronic viewfinder anyway. But don't look through the viewfinder on a traditional DSLR through a long lens at the sun. If you can, just don't do it. It's not worth the risk. So not suitable. UV protective filters, they're not going to do the trick. ND filters, polarizing filters, ND grad stacked filters, you need a solar filter. And I'll talk through some options on that shortly. So very quick Eclipse primer, just to get everybody level set, as I mentioned. This was the annular eclipse last October. This is where the moon is farther away from Earth. So during annularity, it's not totality because it doesn't quite cover the sun. This is a photograph shot through a solar filter. You have to have the filters on for the whole thing during the annular eclipse, because the edges of the sun, the limb, remains exposed. And so you get this sort of ring of fire, as it's nicknamed. Whereas in a total eclipse, and what we'll be seeing if you're in the path of totality on April 8th, you see a whole lot of different things that you can't see any other time, which is the corona. That's what you're showing in this shot. The diamond ring. So that's what this is. This is where the last little glimpse of the sun's photosphere, the bright part, is obscured by the moon. You can see a little bit of pink around here. That's a hint of what's called the chromosphere. You can see it better here, chromosphere and a prominence. So this is the outer atmosphere of the sun. It's not atmosphere in the sense of breathable, of course. It's extremely hot, but it shows up in this pink, which is related to the chemical composition of hydrogen. and that becomes visible in a total eclipse. You might think, is that chromatic aberration? It's not. It's the chromosphere. I mean, you might have some chromatic aberration as well, but that's by the by. This is a real phenomenon that you'll see in the eclipse. And then we have things like Bailey's beads. So Bailey was a English astronomer in the early 19th century, made a lot of money, started doing astronomy when he had enough money, and he was the first, not the first to observe these, but the first to describe them in the literature. And this is where you see the last traces of the sun shining through the valleys of the moon. So we'll talk a little bit more about that later. So let's go through the contact times, just terminology, probably familiar to pretty much all of you. C1, the start of the partial phase. I've put this 10 minutes after C1 just so you can see it. But C1 is when the moon kisses the sun for the first time, as it were. The limbs are touching. C2, max eclipse, and C3, this is where all the action happens. Diamond ring disappears, corona comes out, diamond ring reappears. And then we're back into the partial phase, and we end at what's called fourth contact, C4, which is where the sun and the moon finally move apart, and the sun is no longer obscured by any part of the moon. So those are the key terms you'll see in eclipse timings and so forth. This is my experience of total eclipses. Your heart rate, it tends to follow this progression. Now, bear in mind that you're waiting, what, an hour and a half between C1 and C2. Then we have between 30 to 7 minutes, typically, for the range of total eclipses of complete excitement. April 8th will be roughly 4 minutes in most places if you're near the center line, and then it's over and we're back into partial. So this is typically how I think most people experience this. And then as photographers, you'll see that the number of shots you're taking per minute, this is obviously not to scale, this is just my rough estimation and sort of indication of what's going to happen, is you'll chunter away taking some photographs. If you're doing a time lapse, they'll be on a regular interval, maybe 2, 3, 4 minutes, or more if you wish. It'll increase as we get towards totality, and there's less and less of the sun visible. And then there's a burst of excitement at C2 and before C2. That's a critical thing we'll talk about before C2. And then we're into totality. The pace can slow down a little bit, but it's pretty intense because you want to make the most of it. But you want to take some time to stop and look and observe and enjoy the experience. Look around you, not just through the camera. Look up, look to the sides, look for other planets, comets, etc. Look behind you, look for the 360-degree sunrise, sunset effect, I mean. Sunset, it's not sunset. And then as C3 approaches, the excitement builds, the intensity builds photographically because of all the things that can be observed at these moments. And then I've put these in outline mode. A lot of people pack up and leave. You don't need to. If you want to capture the full sequence, you would go back to doing essentially the mirror image of what you'd done from C1 to C2. And of course, what that means is that at the time of sort of greatest emotional and visual impact, especially if it's your first total eclipse, and particularly around second contact. Oh, I messed up my labels here, but you know where they are. At the time when things are changing the most for the camera and for your gear settings, you've got to be at your most switched on. So that's why it's a bit of a challenge. What does that mean? Rehearsal. Talk a little bit about the difference between practice versus rehearsal. I think there are a few key differences to think through. But if you're going to make the most of it, you want to be well practiced and well rehearsed. So practice, I think, is sort of a task-focused thing. You're looking to improve a specific skill or area of knowledge with your camera. So how do I acquire focus? And you might try that on the moon, for example. How do I shoot a bracketed set of exposures. We'll talk about that in detail shortly. It's repetitive. You can take your time to get it right, and you can control where and when you do it. A rehearsal is different. You're performing a whole bunch of tasks in sequence, and you're doing it on somebody else's schedule. If you're in a theater, you're not practicing your lines anymore. You're delivering them in response to other actors. And it's similar with as photographers. We've got to get things right at the key moments, because it's short, and if you miss it, you've missed it. You've got to get it right when it matters, and you don't have complete control over the environment. You're going to be surrounded with other people. They could be very excited. There'll be other photographers. You don't entirely know what's going to happen. So I would encourage you to do both of these things, and we'll talk a little bit more about specifics on what you can do. So now what I'll do, I'm going to show you a quick demonstration, not spend too much time on this, quick demonstration of some of the capabilities in Photo Ephemeris to give you Eclipse information. I'm not going to try and share my iPhone, because I have got so much going on this morning with this presentation. I thought that's just one more thing that I wouldn't cope with. So this is just a screenshot from the current version of Photo Ephemeris for iOS. It's in the App Store. And let me tell you what's in there. You have the Eclipse path for April 8th is there. It's included in the app. It's available offline. You have the local circumstances, so the contact times we talked about, C1, C2, C3, C4, in the timeline. You have what I call the mini Eclipse simulator down there to the left. I can zoom in on that a little bit. And this is where you adjust the time of day, and this gives you an indication of when you're in totality or partial. And if you tap that simulator, it pops up the full simulation, which I will show you shortly live. And from there, you can choose C1, C2, max C3, C4. You can choose halfway between C1 and C2, that's that dot, or between C3 and C4, that's that dot. Or you can choose 5 seconds before C2 for diamond ring, or 5 seconds after C3 for diamond ring. The red warning triangle indicates that eye protection and camera protection is required, and that's related to when the sun is not fully obscured. So there's a bunch of tools there. They're very similar to what you'll see in the web app. So that's the current version of iOS. I've got some new stuff to show a little bit later on, which I'll come back to. But let's just jump into the tool. This is our web app. It's at app.photoephemeris.com. You can sign up for free. You can use it for free. You can sign up for a free account, and there is an option to purchase a paid subscription if you'd like access to all of the features. But let's just go to April 8th, 2024. And if I zoom out the map a little bit, you'll see there is the path of the eclipse, and these dotted purple lines are the lines of equal magnitude of the partial eclipse. So for example, I take the red pin, I drop it there, and here in the timeline you can see that is the magnitude is 0.8. So that means that essentially it's the fraction of the sun's diameter that is obscured by the moon at the time of maximum eclipse. So that's what the partial lines are. And then the pink line, which is in chromospheric pink, if you will, is the line is the path of totality. You can see it's somewhat wide. You'll have seen this from other maps. If we measure from there, I'm going to use this extra map pin, and I'm going to drag and drop it here. Just collapse that. And you can see that it's about 121 miles across in this part. It varies as you go. So we have eclipse paths. You have contact times down here. If I drop this pin on the center line, well, anywhere really, I'll drop it there, wherever that is. Suntown, can't see what it's called. That's Greenville, Texas. And then if I choose second contact, we get an eclipse simulator will pop up. Anytime that the time is selected between first contact and fourth contact, the simulator will pop up. I can put that on, say, 5 times real speed, and I can play it back. You go to 5 seconds before, so you get a feel of how that goes. There's the shadow disappearing. You see the time advancing. Time to the next contact, that's the magnitude increasing as we approach maximum eclipse. The sun is 100% obscured. So that's the mini sim. Well, this is the mini simulator in the web, and again, you can expand that by clicking here. There is a full screen view of that simulator, and we can play that through again. I'll just leave it on real time, and you'll see diamond ring receding, Bailey's beads disappearing, the coronas coming out, getting stronger. You can click through to max time, you can click forward to C3, you can click after C3, or you can scrub through the partial phases like that. There are a bunch of other controls related to Bailey's beads, which will I'll show you those very briefly. If I put this outline view on, then the simulator will show you the beads, and if I just play that, watch how they disappear as we go into totality. There we go. And this orange line is the rough limb of the moon, reference to the average limb of the moon. So if you're really into capturing some of these phenomena, such as Bailey's beads, you can use this tool to explore locations and see what beads might be visible. Let's just have a look at C3 out of interest. It's going to come out down here. And here you can see that we're in an area where the limb of the moon is a little bit rougher. It's below the average. So what you would expect with that is that at the time of C3, there's already some beading visible. So in theory, totality is slightly shortened in this particular location. If I go back 10 seconds, click play, just watch what happens here. Zoom right in so you can see it come out. There they come. There's all the beads. So this tool is useful for the detailed exploration of exactly what you can see in different locations at C2, C3. One of the nice things, I think, particularly in the web version, is that without having to jump around between pages, you can just drag and drop the map pin to your potential spots for the eclipse, and it updates immediately. I'll go back to C3. So you see in that location, the limb is more close to the blue. There's no beading at C3 when I've come down here relative to the center line. Let's go back up there. Beading at C3. Down here. No beading at C3. So it's a very easy way to flip back to explore different spots, look at alternatives and so forth. So that's the Eclipse simulator. Again, if you're really into this, come down to help. There we go. Look at this article, Advanced Solar Eclipse Planning, and that covers this particular tool in full detail. And it will talk you through how to use these sliders for the Bailey's beads exposure and resolution, plus this control for the solar radius. That really is sort of an advanced thing for more eclipse experts. If you don't know what I'm talking about when I talk about the solar radius, you almost certainly don't need to worry about it, and you don't need to change the default. It's a good default for what you'll see. Okay, so we're 33 minutes in. Let's have a look where I'm at. Okay, so yeah, so let's just talk a couple of questions that came in that I'd like to explore. We had somebody ask, what are good locations or cities in New England to view the eclipse? So let me just show you quickly how to look at that. Well, I'm not super familiar with the exact geographical definition of New England, but I'm thinking it's sort of here, and the path is up here. So you're not going to see a totality if you're outside of the path. So we can click a random location west of Boston, click max eclipse. I'm using 2 fingers on my trackpad to adjust the zoom there, and that's what you will see at maximum eclipse in this area. As we go north into Vermont and click max eclipse again, it gets thinner. And once we get further north, max eclipse, you're into totality. So you can use this red pin to explore the timings, explore what you're going to see, and then in detail what you might be able to photograph. Okay. Oh, thank you, David. New England includes, I should have checked this before I embarked upon this part of the demo. VY is, I'm guessing you mean Vermont, New Hampshire, and Maine. Okay, so yeah, so there we go. So let's go to Burlington and have a look there. Okay. Second contact, third contact. If you click on C2, it'll tell you how long it is to C3. So that means you're getting 3 minutes, 16 seconds of totality in that location. One thing to be aware of is how does the length of totality change as you go across the path? So I'm talking about in this axis here from north to south, broadly speaking. On the center line here, I click C2 and we have 3 minutes, 32 seconds. If I come halfway down, click on C2, I still have 2 minutes, 56 seconds. So some maps, I haven't got it in mine yet, but some maps you'll see in Michael's maps show this. They'll overlay the outline of the shadow of the moon at a particular point in time on the eclipse path. And it basically looks like a circle. And the circle sort of tells you, it's a clue to how long the eclipse is going to last. What that means is that if you imagine a circle running sort of as my mouse is describing here, it means that the duration of totality shortens very quickly towards the edges, but not so quickly as you move from the middle, because you're sort of describing the circle, if you will, of the shadow. So let's just come down to the edge here, pretty close to the edge, and click C2. So we still have totality, but now we're down at 40 seconds. So that's how you can explore that. One more location to look at. I have a link. So somebody asked, I'm sorry, I've missed the name of whoever asked this, but thank you for the question. What can be seen in England for this total eclipse? So let's jump in there. The answer is you're not going to see totality. We are, if I just zoom out, we're sort of in the partial zone. We're not in the pink area. But if you were to hop up to the outer sky, for example, or lots of locations on the northwest of England, and I've come here at 8:20, 2 minutes before sunset, you will see a partially eclipsed setting sun, weather permitting. Let's just explore that a little bit more. There it is. And that could make for a very nice shot. And at sunset, of course, the sun is coming through loads of more atmosphere, and it's possible to shoot that without a filter, as long as you don't keep shooting for 2 hours at the sun. But if you wanted to grab a few, just pre-sunset shots, you can do that without a filter, I think, pretty safely. We've all photographed sunsets before and not damaged cameras, but that's when you're not doing it for an hour and a half of constant shots through a telephoto lens. When it's bright and at its brightest in the sky. So those are some locations. I know I'm seeing other questions coming in about other locations. I would encourage you to just come and explore this for yourself. You can jump around this map freely. You don't need to have the paid plan to do that. You can just drag and drop the map pin. You can go to Florida, click Max Eclipse, and you'll see that you're going to get a 0.651 magnitude partial at that point. Okay, let's look here. Right, I'm going to come out of here and go back to my presentation. We're at 10 past 11. I've got about another 10 minutes of slides, and then we're going to go back to Michael, and we'll hear from an experienced eclipse photographer on what he has seen. Solar filters, I had loads of questions on solar filters. We need these for the partial phases. We need to take them off for totality, before totality and just after totality. We'll talk about the timing of that shortly. Here are some examples of filters that you can use and what they get. This is a Baader film. It's from a maker called Star Guy. I think he basically buys the film from Baader and mounts it, puts it into a Eclipse, into little frames. It's a thread-in filter. It gives a slightly white blue tinge to the image. This is a Nisi solar filter. It's a glass filter. I'll show you these shortly. I have them right next to me. That gives a very white image. And this finally is Thousand Oaks optical black polymer. It's a sheet that literally we put over the end of the lens with an elastic band. So they all give different colors. None of these colors, well, that's probably the most natural color. The sun really is white. The orange that you're seeing here is not the color coming from the sun. It's the color of the filter material. It's artificial. That's not to say it's unattractive. It is quite attractive, and I think a lot of people like it because of the way it suggests what we mentally associate with the color of the sun. And then the blue white here is partly a reflection of the material, not the true color of the sun. This next slide, this again is another shot with the film on. One thing, let me just go back. I did put exposures in here. So grab a screenshot of this if you'd like to know what these exposures are. You really need to test your own solar filter. They all seem to behave slightly differently depending on the material. So it's difficult to give hard and fast guidance as to what exposure you're going to need. You need to test it. You don't need the sun to be eclipsed to test it. You can go out on any sunny day and try it out. And I would encourage you to do that. Here's another one with the Baader versus I got another Thousand Oaks optical. I'll show you all of these next. Very different exposures reflecting different material behaviors. You can see the histograms there, which sort of give you clues to the color differences. Two comments from my experience. Your experience may be different. The Baader gives a crisp, sharp image. There's quite a lot of detail on it. The Thousand Oaks is considerably softer, and you get this sort of glow fringing effect around the sun, which is quite nice, but can make it harder to composite these images. If you're doing a sequence, you've got to deal with how masking out all of this stuff. On the Baader, you don't so much. So this, the Baader filter, that was as it came out of the camera. That was after I did an artificial color correction in Lightroom to make it similar looking to the Thousand Oaks color. It's more attractive, but you've still retained all the detail. You don't have the fringing. So that's some considerations. Let me just stop my screen share and I'll show you these quickly. So stop share. All right, here we go. Here's the first one. Hopefully you can see that. It's a Thousand Oaks filter, Thousand Oaks optical. And this is one that you push onto the end of your camera and there's felt that's stuck onto the inside of it. And the advantage of this is that you can pull it off just at the key moment. So here's, look at my camera. Hopefully I won't drop all of this. That would be sad, wouldn't it? So camera lens, can you see that? Let's see if it'll come into focus. Doesn't seem to want to, there it is. Okay, I put it in front of me and it focuses. And it pushes on like that. It sits on the end. Then you can take it off quickly before second contact, put it back on quickly after third contact, and your camera's protected. That's that one. So easy to use. You can get these with other materials as well from various manufacturers, but this one is soft, I find. Here is the Baader film filter. This one is a screw-in filter. It's very shiny. Let me put it, there we are in front of me. You can probably get my own reflection in it. And it's a screw-in filter, so this is a 77 mil. It screws into the end of your lens. You can get one in the right size or larger than the lens you need with an adapter ring, and that will work. Downside of a threaded filter is it takes longer to remove and to put back on. But if you're not too concerned about getting filtered photos of just before second contact, you can take it off at your leisure a couple of minutes before, put the lens cap on, and then take the lens cap on and off quickly for third contact, second and third contacts. Here is the Nisi filter. This is a glass filter. I used this for the annular eclipse in October. This one, it's not safe to look through. It's a glass filter. You can see how dark it is. Nothing coming through that at all, of course, as you'd expect. When I took this off at the end of the annular eclipse, we photographed the whole thing. It almost bent my fingers. It's an aluminium frame. I think it captures an awful lot of heat. It's a measure of the power of the sun. And then the last one I'll show you. This is hold on, there we go, there. Black polymer solar filter sheet, 6 inches by 6 inches, 1000 lux optical. And Alice used this on her camera, just elastic band over the end of the lens. And it doesn't matter that it's a bit crinkly. It doesn't really affect the shots. It does a little bit maybe, but it's not. You can get reasonably sharp shots through that. For some reason, that material is sharper than the other 1000 lux one that I showed you. That's solar filters. Let me start up the screen share again. Screen share. There it is. Okay. Now, time is marching on, so I'm going to have to get through these quickly. Things to shoot during the partial phases. We're going to be at a solar maximum. There could be lots of sunspots. You can photograph big sunspots about to be occulted by the moon. You can see in this shot, this is at 500 millimeters. There's the exposure information. This was through the Nisi filter that I showed you. You can see the limb of the moon, the roughness there. That's what causes the beading. So think about those sorts of shots. One essential technique for your eclipse photography is exposure bracketing. So exposure bracketing, not all cameras have it. Many do. If you don't know whether your camera has this feature or not, get out the manual or a guidebook and read about it and try it, practice it. This was from 2017. I shot a 9-frame sequence, one EV apart. That's one stop. And the thing that I'm varying on this sequence is the shutter speed. So the aperture stays the same. This was the base exposure, ISO 100, f8, 80th of a second. And then the camera will automatically, in continuous shooting mode or with a shutter release, it'll shoot 9 frames, and it's -4, -3, -2, -1, all the way through to +4 relative, to this base exposure. And your cameras may have different bracketing patterns they can use. But this is almost a surefire way to capture a range of interesting phenomena. You can see in this shot, you can see chromosphere and a prominence there. There's a little bit of chromosphere sort of left around here, hints of the corona. And then at the +3, +4 exposure levels, you get much more corona. And I think if I were going to redo this, I think this base exposure is possibly too short. I might have gone to a 40th, because I'm not sure there's a ton of useful information in this -4, but I'm pretty certain that there is more corona to be captured if I'd gone to +5. Again, Alan Dyer's book is very good on this. The Fred Espenak page is excellent on this. They have tables with the relative exposure settings that you can use. If you want to be successful at bracketing and to capture as much as you can during the eclipse, you need to have a fast camera. But the faster your card writes and the faster the camera, the more shots you can get before the camera will buffer. So what you should do with your camera, put it into continuous high shooting. Let's try, here we go. No?
Is it focus?
Is it focus? Okay. You see what I mean about practice here, people? Can I just put it in manual focus? Okay. That's buffering. That's it. That's all it can do. So if that's your card write speed during the eclipse, you're sort of in a bad place. And you see the green LED, that means it's still writing the images to this card. That's the slowest card on this camera. In the interest of time, I'm going to skip through to this other camera. This is a Nikon Z8. And we put it into continuous high. You hear that? There we go. Shoots non-stop. So think test that out, because there are a few things you need to do. One, you need to know what your camera is how it's going to behave. You need to know when it's going to buffer. You need to budget your shots for the critical moments of the eclipse in order to not end up in a buffering situation right at the key moments when you can't capture something. So top tip, I think, for preparation is to work out what your equipment will do. Buy a faster card if you don't have one. Very quickly on field of view. I'll put these links online, but at different locations along the path, the circumstances are different. You can explore that in the tool. So the range of azimuth across the sky and altitude between C1 and C4 is going to change. So if you're trying to shoot the whole sequence as for a composite, your camera is going to sit in one position, and you need a field of view that's wide enough to cover it. So these are some of the numbers that I came up with. So in Mazatlan, for example, I'm missing an accent there, sorry about that. 17 mil, 16 mil, whether you want the horizon in the shot or not, in landscape. Well, this is on a full frame camera. In Carbondale, in the middle of the US, you can increase to 30 millimeters without the horizon, 20 millimeters with the horizon. Newfoundland, things change a lot, and we're more constrained vertically because we're closer to the end of the path. And so there's more movement down and across the frame than there is down the frame than across the frame. And you can have a longer length lens and still capture everything. But still relatively, it's a medium length for the vertical shot. So that's field of view. You can check these times in Photo Ephemeris, go to C1, look at the azimuth altitude, go to C4, check it out. Then there is a field of view tool that you can plug your camera format in and check what field of view you're going to have available. There are other tools available online that will do this for you as well, but that's field of view. Practice and rehearsal, moonrise, practice on that. This was us practicing last night. Practice with the moon at the eclipse altitude. You can see how extreme this is. We're going to be in Mexico for the eclipse, and the sun's going to be at plus 69 degrees. You need to make sure you can handle your camera, see the screen, focus effectively. So you must check it physically that the ergonomics are going to work. You can shoot the sun with a solar filter, try your bracketed sequences, and rehearse the shootings with actual eclipse timings. I'll show you some more about that later. And be comfortable. So temperature management, don't get too hot, too cold. Shade your gear. These were little hoods that Alice made for our cameras, which were fantastic. You can take those off probably for totality, but for the hour and a half either side. And then, your basic needs and comforts: water, eclipse glasses, hat, water gloves. Don't do these things. This is my last slide before we bring in Michael. Upgrade your camera or lens firmware on April the 7th. Not advisable. Shoot on untested equipment, including memory cards that you haven't used before. Try out new camera settings on the day. No. Don't forget to remove your lens cap, like I did at C2 in 2017, or your solar filter during totality. If you do, you won't have any photos. Don't turn off your camera while it's still writing images to the card. That can risk corrupting the card. So look for that green LED or whatever your camera has to show that it's still writing, and don't turn it off by mistake, because you'll have been shooting a lot of images, I expect. And then don't forget to replace the lens cap or the filter after totality. Okay, wow, that was a marathon. So with that, Michael, welcome back.
Hi there.
Let me stop my share. Michael, you photographed how many eclipses?
Well, I've seen 11 total solar eclipses and 4 annular eclipses. And at every eclipse, I've tried different configurations, sometimes just as simple as running a GoPro to capture a nice video of the landscape and the shadow racing across the sky. But I wasn't particularly successful with detailed images of the corona until my most recent eclipse last April in 2023. And I can talk briefly about the factors that finally led me to some success, but maybe I should speak to that when we go through the photographs that I sent you.
Yeah, yeah. Well, maybe just well, why don't we do that first, and then we'll come back and talk about the maps. So I'll share my screen.
Yep.
You want to start with the 2023 eclipse, and we'll do the partials afterwards?
As you wish.
Okay. Well, seeing as you mentioned that one, let's start with that. How's that? Tell me
So
what
this,
you like.
okay, this is an image that I captured last April. Um, and somebody asked in the comments, is it possible to do eclipse photography from a ship that has some rolling motion? And the answer certainly is yes, although primarily for the lower or the shorter exposure range, it'd be difficult to capture a longer exposure of several seconds to capture the full extension of the corona from a ship. But other than that, you can be very successful on eclipse photography on a ship. But the problem that has that bedeviled me for several eclipses when I tried to shoot with a DSLR and a long telephoto lens was focus. You know, the focus was always a little soft. And I was in last April, I was traveling with my friend Fred Espenak, and he told me first acquire your focus. Before the eclipse, and then tape down the focus range so that it can't budge at all, because there are so many different things that um, that can just tweak that focus and ruin an otherwise perfect eclipse shot.
And
So
I think Michael, that makes sense if you're keeping a fixed focal length for the duration of the eclipse. If you or you know that your lens isn't subject to any focus breathing, which is where sometimes the focus it can change slightly if you change the zoom level, perhaps. Do I have that
yeah,
right?
yeah,
Yeah.
that's right. That would be for if you're using a yeah, that would be true for a particular focal length. And then the other thing that, since I was on a ship, I didn't use a tracking mount. It's not practical to use a tracking mount on a ship for obvious reasons. But what I found was very useful was for past eclipses. I used one of those ball mount tripod heads, and those just they're great if you're finding a given spot and just focusing on a particular spot. But if you need to do a little pan and zoom motion, I found that a gimbal head on your tripod works so much
Yeah.
more easily for getting it framed just right. Just look up gimbal head for tripods,
Yeah.
and there's a variety of them, and those work great for me, especially if you were on a ship. And then let's see, can we move to the next slide?
Yeah.
Okay, this is an image that I took. You mentioned that bracketing the different exposures, and the point of that is not simply to capture different parts of the corona, but that also gives you the possibility to do some post-processing and merge the innermost bright part of the corona with the more delicate, faint outer corona. And so you can really make some of the overall structure of the corona pop out. So this is an image that I did some post-processing on that used 7 different bracketed images to produce.
There's some very interesting features in this one. You can see there, I notice what
Yeah,
looks like some sort of CME, possibly. Maybe that's
it
a
looks
part of the
like
sun.
it looks like a small coronal mass ejection.
Yeah, and maybe there's some good
What?
rings down here as well. That might be.
Yeah,
Yeah.
yeah,
So there's a ton of detail in all these images, and that's why I think you capture different exposures. You were varying your shutter speed for the sequence,
yeah.
Michael?
I just programmed my Nikon to to just take a bracketed series, just like you talked about earlier,
Mhm.
and then join them together, and then you can do bring out more detail than you would see in any individual image. So that's a good thing to do.
Yeah.
All right, next.
Number 4. Hey.
Okay, yeah. Well, let me talk about some interesting things you see in this photograph. And one of the most exciting aspects about the April 8th eclipse is that we are approaching and very near to the maximum of the 11-year sunspot cycle of the sun, which means that we've got a greater possibility of seeing dynamic features such as this amazing prominence that's rising straight up at around 11 o'clock. That was probably the largest prominence that we've seen at a total solar eclipse since 1991, which was my first total solar eclipse. In 1991, we had two amazing prominences like this. So I think the features that we saw last April, we're approaching solar maximum, but now this coming April will be closer to maximum. So we've got a higher probability of seeing some very interesting features. And then if you go over to around 2 o'clock on the limb, there's an amazing feature there. That's an eruptive prominence, or also known as a loop prominence. That's a beautiful structure. And that's the first time of my 11 eclipses that I've seen a feature like this. Some of the things, and then other features that we see in this photograph are towards the left side next to the Bailey's beads. We see an extended length of the chromosphere, the sun's chromosphere. The pinkish glow that you see in both the chromosphere and some of the prominence is the hydrogen emission line. And so we can look forward to a very active sun on eclipse day. There are two things that anyone, an experienced eclipse chaser, really wants to see, and that would be a big coronal mass ejection during eclipse. In the year 1860, there were a series of drawings made of the corona from that eclipse. The photography, of course, wasn't advanced at that time, but the drawings showed these amazing hook or bubble-like features in the corona. And if we were so lucky to have something like a coronal mass ejection during that eclipse, that's going to blow all our minds. If we could see that and capture that with today's photographic equipment. The other feature that eclipse chasers are dying to see is a larger version of this loop prominence here. And for the 1919 eclipse, the famous eclipse that validated Einstein's theory of relativity, there was an amazing eruptive loop prominence. Like it had a similar appearance to that, but probably 10 times larger. You can Google for images of the 1919 corona and see what that looks like. So that's what we're hoping for and hoping to capture.
One more small feature might be worth pointing out. Here you can sort of see some chromospheric beading, where the
Yeah,
lunar limbs are breaking through the chromosphere.
yeah.
That's the same thing that causes Bailey's beads, but it's just that all that's left is visible is the chromosphere rather than the photosphere. And you can simulate that in Photo Ephemeris as well. It will show you chromospheric beading in the
Oh,
simulator.
really? Oh, that's cool.
It's based on a sort of average height of the chromosphere, so take it
Yeah.
as a gauge. Yeah.
Okay.
Should we look at the next one?
Yep. All right. And then this was kind of my takeaway. I took all the images, and was able to develop this composite. In the middle row, of course, what you see is the first diamond ring on the left, and then the corona at mid eclipse. That was a process of several different exposures together. And then the diamond ring at third contact or end of totality. You'll see, of course, that the diamond ring, if you are in the center of path, it will be on the opposite side of the sun. But if you are on the side of the eclipse path, then they would be closer together. But this is an example of what you can do, with your images afterwards.
Yeah, it's great. It's a lovely sequence.
Okay.
Should we
And
talk about maps? Oh no, you had.
actually, yeah, let's talk about this.
That's better.
There was a question about observing the eclipse from the UK, and the answer is, well, you've got a partial eclipse, as you showed with your simulator. In June 2021, I went to New Jersey, and I selected the location because with the simulator, I wanted to capture these horns of the eclipse rising together at the same time. So this is a lovely sequence that I captured at a partial, well, it was actually an annular eclipse on that day, but it turned out that this was during the peak of COVID, and it was impossible to travel to Canada where you could really get a good view of the annular eclipse. So I did the next best thing. I went to New Jersey where I had a deep partial eclipse and captured this amazing sequence. So partial eclipses can be very interesting photographically if you can find them right at sunrise or sunset. And if people want, there's another opportunity very similar to this eclipse on March 29th, 2025, just over a year from now. And the places where you can, the ideal locations for the same circumstance would be in Maine or in Quebec, particularly Quebec City. Um, and so we've got another chance for a beautiful sunrise partial eclipse just over a year from now.
So, Michael, one question: did you use any filters on your camera for this?
No filters.
No.
No filters, because I was at sea level. I live in the Rocky Mountains, and I can't look at I can't look at the sun at sunset or sunrise because of our elevation and our sky clarity. But at sea level, and with the humidity in the air for a brief time, you can safely look directly at the sun and photograph the sun without filters.
That's why your solar panels work better at altitude, given the same orientation than they would at sea level, because the air mass through which the sun's light is passing is so much greater at sea level than it is when you get elevated.
Yeah, and at sunrise and sunset, you have this amazing refractive effect that squashes the shape of the sun. So that's a
If you
beautiful.
like this one here is sort of really shows that nicely.
Yeah,
Yeah.
yeah.
Excellent. Well, so
Okay.
that's great. So I think that's some really good ideas for folks to know about on what to focus on, and you all know how to work out the timings of these things now. So let's talk, Michael, a little bit about math, shall we?
Sure, let's do that.
Okay, I'll let you take the lead on this one.
Okay, well, Stephen, in January, I saw that you published a wonderful page on double diamond rings, showing your how your tool can be used to locate the double diamond ring. And the maps that I produce for finding the double diamond ring are a perfect complement to your tool, because what these maps show was that I was able to figure out a way, and I at the very bottom of the page, you don't have to scroll to it now, but at the very bottom of the page, I describe in brief the technique that I use to draw these lines. But these lines show where you can be to find a double diamond ring either at second, the beginning of totality, or at third contact, the end of totality. The blue line or the green line shows the double diamond ring at second contact, and the blue lines show double diamond ring at the end of totality. And a couple of pieces of advice I would give about this is that try and pick if you're interested in seeing or photographing the double diamond ring, don't sacrifice any significant amount of totality. For example, if you see a nice ring or a nice line on the edge of the path, unless I wouldn't advise you to go to the edge. Concentrate on these lines that are towards the middle of the eclipse path. And so these lines predict where you will see the double diamond ring. And yeah, you can scroll down those. There's
There's
actually
one for each sort of region, isn't there, as we go across?
Yeah, well, there's actually 14 of these maps that you can go through and pick your location.
And if I open this in the new tab, you can zoom in a little bit closer there, for example.
Yeah, yeah, but the because this transition or because these locations of the double diamond ring are very sensitive to your location. Um, I advocate that you use my maps for an initial determination of candidate locations, but then use your tool or similar tools that do the detailed Bailey's bead simulation to really identify the precise location where you can capture this beautiful view of the double diamond ring.
Yeah,
So,
I think
so
they're wonderful compliments. So in addition to these double diamond ring maps, Michael, you have maps that show sort of the outline of the lunar limb as it's you have videos showing it simulating across the ground, which are fantastic. And the transportation links, so drive times, visitation numbers. So if you're thinking about options, one of the things I said I'd talk about today, and I realized I haven't, was weather. But one of the things you want to know about is, for example, Mount Pleasant. I'm just picking off the top of my head here. There's a bunch of major roads going in all directions. So if you're weather affected, you've got potentially some options. Although I think traffic in Texas is going to be tough in pretty much every circumstance.
yeah.
But these are things you can look at on Michael's site for visitation numbers, travel times, and sort of do your general planning from there and more specific planning with a tool like Photo Ephemeris.
Absolutely.
Um, sorry.
And you were spot on with your comment. And as for planning, of course, the number one factor in planning is choosing a site with good weather prospects. And the second most important factor is mobility. So that, for example, my location, can you go back one map? The location that I've chosen is Fredericksburg, Texas. And if you look at Fredericksburg, um, Fredericksburg is very close, and Kerrville as well, is very close to the center of totality. So we're going to have about 4 minutes and 24 seconds of totality. But what's also important about Fredericksburg is you'll see there are 6 highways radiating out of Fredericksburg. So if eclipse morning presents patchy clouds and I need to relocate, I've got 6 choices to relocate. So that's how an eclipse chaser thinks.
Yeah, that's great. And you've got a bunch of double diamond options in several
Yeah,
directions, which is nice.
yeah. And,
So,
and
so sorry, go on.
another, uh, like when after I made these maps, another fascinating possibility occurred to me. And that is in this map, you see how there's two pairs of blue and green lines that are pretty close together. If in other maps, you'll see that these blue and green lines actually merge and join together. And what that means is you've got
Yeah.
the chance for a double diamond ring at both the beginning and end of totality. So if somebody wants to see that, use my maps as an initial locator and then use the photo ephemeris to really pin down the precise location if you want to see an image, a double diamond ring.
We found a couple of those in Mexico yesterday, I think. So I
Yeah,
picked one of these convergence points, roughly dropped the pin on that in Photo Ephemeris, checked the contact times in the simulator, and indeed you get a double, and in one case a triple diamond at
yeah.
C3, which
I
was
yeah.
cool.
I
So
was
time
surprised.
time is against us, I realize.
Okay.
We have one more thing to go through, and this is the grand summation of everything we've talked about. Thank you for sticking with us, everybody. Um, what what I did, I thought, right, let's take Michael's map of the double diamond, and let's combine it with a question which one of you kindly asked. I'm going to open this in a new tab, which was I'd like to photograph the total eclipse behind a lighthouse or a bridge. How can I plan that? How can I get my position set up? So I thought, okay, how about a double diamond behind a lighthouse as a random challenge? So here's what I did. I looked on Michael's map up in Newfoundland. I started in Newfoundland because it's later on in the path, as we've already looked at, the sun is lower in the sky. So if we're putting it behind an object, it's much easier than it's going to be, say, in Mexico or Texas, where it's much higher in the sky. Looking at this line, these lines here, I started looking on Google for lighthouses. I found a few and I checked them out. So let me show you what I found, so you can see the plan here. So this is roughly on the line. There is a lighthouse that's on one of these double diamond lines. And I just come here, paste that in. Oh no, that was my Google Maps search. There we are. It's this lighthouse here, Heart's Content Lighthouse. Isn't that a great name? So that's how you can find lighthouses. Google will tell you those. Lighthouse near Gander. That's what I put in. Gander is that famous town in Newfoundland where they looked after people after 9/11 when they were grounded. So here is the shot. Put the satellite maps on. So it's one of those funny situations where this is the direction of the eclipse. You can't do anything about that. So if you want the sun and moon eclipsed behind a lighthouse, you need a lighthouse that you can get to from the northwest. So you need to be one that's accessible, ironically, on the east coast of the continent, but with a view back west. So that's what we have here, which is remarkable. I'll show you in street view so you can get a sense of where we are. There it is. There's the lighthouse. It's about 30 feet tall, so you can plumb that in as a building height. And if I expand the sightline tool, you can see that at third contact, there's the sightline from the shooting position. The sun and moon passing over a few feet above, they'll be roughly there above the top of the lighthouse. You can see there's the gray pin set at 28.5 feet. There's the sun and moon just above it. And here in the simulator, I'll just maximize that, there is your double diamond. So that's the sort of thing you can plan if you put these tools together. The very last thing I'm going to show you, and Michael, you and I can sort of react to this as we watch it. I have a little video. We're going to watch this very eclipse in that location in the simulator and look at the timings alongside it. So let me just pull that up, share. Okay, here we go. Let me just click play on this. So we're going to watch it twice. I have the web tool here on the left. It's all set up with that shot that I just showed you. And on the right, I have, it'll be coming into view any second. Here is Photo Ephemeris iOS. This is a new version, which is going to be available in beta next week. I have some new tools in here. You can click this new button, get a vertical timeline view, and then get a little countdown timer, which is generally usable for any event, not just eclipses, but here it's being used for the eclipse. Hopefully I put the sound on. I can't remember if I did or not. We'll find out. You might hear the announcement. So here we are. We're coming up to second contact. We're a minute away from second contact. So what are you doing as a photographer? You're thinking about it's going to be soon time to remove the filters.
Second contact in 60 seconds.
Did everybody hear that? I don't know if you can hear that announcement. Good, yes, we can. Good. So there's the announcement. 60 seconds to go before second contact. You can see how this is sort of looking like the filters on type sun that you might capture. At some point, I programmatically take the filter off. You'll see that. It sort of happens at around 20 seconds. Here's the next announcement.
Second contact in 30 seconds.
30 seconds out. So you really want to get that filter off. You can do it safely, probably anytime within 1 minute of C2, and put it back on within 1 minute after C3. Here comes corona. The beads are disappearing.
Stand by.
15 seconds to totality. So we're into a standby zone.
Second contact in 5, 4, 3, 2, 1.
Diamond ring's gone, beads have gone. They're the same thing. Corona is out. This is a short eclipse because we're near the edge of the path. So
stand by.
Stand by. 15 seconds. So now we're shooting for the corona. You've got your 9-frame bracketed sequences or whatever you're doing.
Eclipse in 5, 4, 3, 2, 1.
Max eclipse will give you minimum chromosphere, maximum corona. That's when the sun is most hidden, more or less.
Stand by.
Third contact, double diamond ring coming up. Watch here.
Third contact in 5, 4, 3, 2, 1.
Here it comes. There's the double diamond. I'm sure I can do better simulations of this, but you get the idea. And now we're 15 seconds post C3. So we'll go through this one more time, and we're just going to switch the simulator into the Bailey's beads mode, the outline mode, so you can really see that. You can toggle that up here at the top right. It's the same button in the iOS app if you're using the simulator there. So here we are again, 1 minute 20 before C2. You can see the limb is disappearing. These yellow lines show you where beads can form even well before second contact. You can see this lunar hill is going to break the photosphere just around here. It's doing it there as well. So there you go, there's a clear break there. So you can photograph this if you still have your filter on. Don't leave it too late though to take the filter off, of course. It's one of those Goldilocks questions. Not too much, not too little, not too late. 30 seconds to go.
Second contact in 30 seconds.
Now I'm sort of programmatically increasing the exposure, if you will, so we get the flaring of the beads. Some interesting beads at C2 in this location too. Anywhere near the edges tends to get good beads.
Stand by.
But you can double check it, of course. And here we go into totality.
Second contact in 5, 4, 3.
There it goes, the very last
2,
bead gone.
1.
Okay, totality. Now you're seeing chromospheric beading because the photosphere is gone, the chromosphere is still there, and you'll see it tracking around because, as Michael mentioned, on the center line, the contacts happen at opposite points. On the edge, they happen across the edge.
5, 4, 3,
Max eclipse.
2, 1.
So we know that C3's, if C2 happened there roughly, That's max eclipse. C3 is happening somewhere around here. And if you are
Stand by.
been paying attention, you'll probably guess that it's that valley and that valley that's going to give us the double diamond ring. I think it is anyway.
Third contact in.
Might be that
5,
one and that one.
4, 3, 2, 1.
Here we go. Yeah, it's those two. There they are. There's the double diamond ring with a couple of spares, but those are the predominant effects. And still interesting beading. 16 seconds post C3, and now it's probably getting too bright and its filters back on. So that just gives you a sense of how intense this whole thing can be as a photographer. There's an awful lot going on. You need to be prepared for all of these different things that can happen. I'll stop my screen share there. And we have 3 minutes until 12 o'clock for questions, but I'm happy to stay on a little longer, Michael. I don't know if that would be convenient for you.
Sure, of course.
We've got a bunch of open questions here. So again, thank you all for the questions. Thanks for staying with us. Let's see what we can talk through here. Oh yeah, so a question from Janine on the Bailey's bead simulations and predictions. So maybe Michael, you can talk about how you do this for your maps as well. But for my simulator, what I do, I've taken some data that was kindly assembled by a gentleman called David Herold. Back in 2010, I think he published it, and it's from a Japanese mission that did a whole. It flew around the moon, did a lot of measurements of the topography and lots of other properties, and from that he extracted the data that gives you the roughness of the moon as seen from Earth in different orientations. So the moon sort of wobbles around a little bit. It's called libration, and so we calculate what is the libration in effect at every particular place and time, pull the profile, and then basically draw the graphics using sort of typical computer graphics techniques to simulate the beads. But for your use, Michael, you do different things with the lunar limb data, correct? For your maps.
Yeah, I describe it briefly at the bottom of my page on double diamond ring. By the way, someone asked where they can find that page, and if you go to the main menu and then you see in the header 2024 Eclipse on the top, pull that menu down.
I'll show you.
Okay.
So greatamericaneclipse.com, 2024 double diamond ring. It's right there.
Yeah, that's how you find that page. There's probably 50 pages on the website, but that's how you find that particular page.
Yeah. And let me scroll down. I'll just so you can. Oh.
Yeah, and actually, could you scroll down to the bottom of that page?
Yeah, that's. There we go.
And enlarge that image there of. Okay, so it turns out that Stephen, earlier you were saying that the moon's shadow has an oval shape. Well, when you make these corrections for the lunar limb through the GIS modeling I did for it, the shadow is actually a polygon, a multi-sided polygon, as you see here. And it turns out that each of those edges of the polygon is defined by the influence of a particular Bailey's bead being extinguished at the beginning or end of totality. But what happens when two of these edges of the polygon meet? That's exactly where you expect to see a double diamond ring, because it's switching from one diamond ring or one Bailey's bead to another. It's described in more detail in the web page, but in a nutshell, that's how I make those maps.
And there are some other great tools that you can find here listed on the pages. Michael kindly has Photo Ephemeris listed, and Xavier Gibier's site that many of you will be familiar with. If you're interested in doing camera automation, this is what you will need: Solar Eclipse Maestro, or there's another one called Eclipse Orchestrator you can use. Eclipse.2024.org also has an excellent simulator. And there's an Android app that does good Bailey speed simulations as well on that site. Yeah, so that's a little bit on the lunar limb and how that's used in some of these calculations. Richard asks, have we used a solar tracker? I have not personally, which is why I didn't attempt to speak to it. Michael, I don't think you said you...
I haven't either. You know, solar tracker is useful for two things. One is capturing longer exposures of, say, several seconds. If you really want to image the outer extent of the corona, and it's also useful if for tracking convenience, as you mentioned earlier, just keeping the sun centered in the field of view.
Yeah.
But you know, it's a nice to have, but it's not a necessity.
Yeah.
Just practice smooth motions with your whatever kind of tripod head you can do,
Yeah.
and you can capture great imagery without a tracker.
A couple of things that I've read about trackers, because I've done a bit of sort of research on them, thinking, should I? Maybe I will, maybe I won't. But one is that if you're shooting at very long focal lengths, like 800 upwards, the tracker can be very useful, because at that point the sun and the moon are occupying so much of the frame that they will move in and out of it, as I mentioned earlier. The other comment I read on a Sky and Telescope article about this was that one of the most common issues with Eclipse photos is focus, which you mentioned, Michael, and with vibration from a tracker that isn't quite up to the job of the load that you've put on it, that you can induce vibration that you could otherwise have avoided. So you need to get the equipment sort of well matched in terms of size and load, that sort of thing. Jeff asks, what is the best focal length? Well, what is it you want to photograph, Jeff? So if you're looking to photograph a wide angle composite of the whole event, then if you're in a place like Mazatlan, I think we came up with 16, 17 mil. So that's ultra wide angle. If you want a shot like Michael, what was that shot you did with the loop prominence that you could see so clearly? Do you remember what focal length that might have been?
Yeah, well, I used 800 millimeter lens for that.
And that might still be that's still cropped a little, I'm guessing, from 800 mil, correct?
Yeah.
Yeah.
Oh yeah, it's definitely cropped.
Yeah. So 800 mil for shots like this, and you'll still be cropping a bit. Obviously, that's not so much of a concern if you have more pixels to work with. So depending on the resolution of your camera, so it's Jeff, it's going to depend exactly what you're looking to shoot. Let's have a look. What else? Oh, this is an excellent question. Dale says, how far in advance can you reliably determine weather permitting, to quote my slide? An eclipse is such a short and non-repeatable event. What are some tips to determine whether to make a trip to an optimal site? So there's one page I did want to share. Let me just load that up and I'll show you this site. I should have had it on my resources list. I do actually, but I forgot to show the slide. Let me share the screen. This one is an excellent site to do your weather research on if you haven't looked at it already. Eclipsophile.com by Jay Anderson, who's been doing this a long time. And he has they're different maps than yours, Michael, aren't they? But they're still great maps for typical weather conditions and cloud cover. You've probably seen these around the internet. They get widely cited. So that's a good tip for checking that out. In terms of the actual weather on the day, I think the consensus is typically 3 days out starts giving you a hint. The annular last October was pretty unpredictable. There were bands of cloud that were predicted that kept shifting in the forecasts. If you go to a site such as windy.com, down here, I'm not signed into it, but I do have their paid plan, but you can pull up different weather models. And I was checking every few hours around northwestern New Mexico for what the cloud cover was going to be. And you can check different cloud layers, different elevations, but it didn't really converge until the day before. It looked like Santa Fe was going to get cloud affected at one point. Then it looked like Farmington was going to be cloud affected, and it all sort of resolved itself within the last 18 hours, I would say. Is that typically your experience as well, Michael?
Yeah. Yeah, Jay Anderson on that page, Eclipsophile, really gives the authoritative advice on that. So I would recommend people read that page that you just showed carefully. And he gives a very specific, 1 week before use this resource, a few days before use these resources, and the night before or the morning of the eclipse, then switch to satellite imagery and so forth, and that's the guidance that everyone should follow is what's given on Eclipsophile.
Yeah, that's definitely an excellent resource to consult. A lot of Jay's maps are looking at historical data and giving you sort of the general picture of what might happen, and then he does update that site with his commentary on some of the weather model updates as they come in for the week before. So check that out. I'm just looking through all the questions. Lots of questions on what focal length did you use for that? So I think we've talked a bit about that for your images, Michael. The ones I showed earlier were shot with a 70 to 300 at around 270. I recall for that bracketed sequence, so not very long, and I cropped them in, and they're nice shots. You wouldn't necessarily be able to print them huge size, but for web use, they're more than adequate. Teleconverter, that's a good one. Michael, have you used the teleconverter?
Yeah, I did, because when I said 800 millimeter, I used actually a 500 millimeter lens with a 1.4 teleconverter.
Yeah. I think the general advice is never go above 1.4 with your teleconverters, because you lose aperture, you lose autofocus ability, you're putting more glass in the path, but 1.4 seems to work pretty well. So that's definitely worth considering if you would like to get extra length on a budget, rather than buying your $14,000 800 mil prime or whatever it is, which I will not be purchasing. So, yeah, one thing I will just point out. Let me show my screen one. I think we'll probably wrap things up shortly. But this I want you to be aware of. If you come to the web app, there's a link up here. Once you're signed into an account, you'll see a link to a forum. We have a community forum set up, and if you click that link, it'll tell you how to sign up for it if it doesn't think you're signed up already. It is a separate account, but please join the community there. We've got about 300 people on there at the moment. I only set it up last month. What I'll do for any questions that have come in that I didn't get to, or things that came in the registration questionnaire, I'll try to follow up on those in some posts in the forum. So please sign up, have a look in there. You just type more sunshine for the invitation code to join, and you can come there. And if you would like to have access to the beta version, or the beta version for my English friends, as different one of those pronunciation things, come into the forum and drop a comment in the solar eclipses category. You'll see I've posted this video that I shared earlier, is already there. Just drop a comment in saying you'd like to try the beta, and I'll get you set up with that. So yeah, I think we've gone 10 minutes over. Thanks for your patience for that. We covered a ton of stuff. Questions have been great. Thank you for joining. Thanks for showing up again. I will send out a recording for this when it's done. Please complete the survey if you can as you leave, or afterwards. And please join us again in a couple of weeks if you'd like to know even more. Michael, thank you so much for joining us today. It's been a real privilege to have your experience shared with everyone. And thank you, Annika. Thank you, Alice, for all your help with production and questions and keeping things running smoothly. And replay hopefully will be available within the next week. So all good. Thank you. I'll stop my share, and with that, thanks and goodbye.
Slán.